This time, on Battle Factory, a personal flying machine that takes surveillance to new heights. A GI jacket that blends into the background. An army base you can pack on a truck and drop on the front line. And an all-terrain vehicle that never touches the ground. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. When this piece of lightweight aluminum is cut and tooled, it will become the frame of a personal flying machine. Strap on the Parajet, take off from just about anywhere, and soar to an altitude of 3 kilometers. Used by military operatives, drug enforcement agents, and first responders, it gets you in and out fast, whether you're carrying a camera or a gun. Since implementing the Parajet, flying cops of Florida's Palm Bay Police Department are now able to spot stolen vehicles and locate marijuana grow fields from the sky. The Parajet breaks down into the engine, the wing, and the airframe. The first step in making the airframe is to machine the base plate. It's made from super strong aircraft-grade aluminum. This is the heart of the airframe that will hold the engine and gas tank on one side and the harness on the other. As the computer-controlled cutting machine carves out the base plate's holes and contours, it is soaked with a coolant that lubricates the tool and keeps it from overheating. Holes are machined out of the aluminum to make the airframe even more lightweight. The same process is applied to all other parts of the airframe, including the pivot arms. The pivot arms are what connect the base plate and the flyer to the wing. They control direction either by hand or by shifting weight in the harness, leaving the pilot's hands free to hold a weapon, a medical kit, or a camera. The Parajet is designed to snap together quickly in the field without tools, so every part is machined and measured down to the fraction of a millimeter. This fit has to be perfect to withstand wind and engine vibration. It can't come apart at 3 kilometers in the air. Once the metal pieces have been cleaned and measured, they're shipped off-site to be treated for strength and weatherproofing. The freshly treated parts are returned to the shop floor and assembly of the airframe can begin. First, 6 spars are clipped to the base plate to form the framework. Curved aluminum completes the cage, which protects the pilot from the propeller blades. A fuel tank is hung on the base plate, which will last for 3 hours of flying. Netting forms a barrier between the flyer's arms and the blades. Finally, the 27 horsepower engine is mounted to the base plate. If the wind is right, the Parajet can carry a flyer at top speeds of 65 kilometers an hour. Next, it's time to connect the harness. The harness attaches the Parajet to the pilot. It gets snapped onto the base plate and bolted to the pivot arms. The propeller is made of 2 lightweight carbon fiber blades. They're fitted together and bolted to the engine. Before the Parajet can take to the air, it has to go through a hang test. This is to ensure it can hold the weight of a pilot. The Parajet is strapped on and clipped to a parallel bar. The suspended tester shifts and stresses the harness to make sure everything is holding tight and secure. The engine is revved to the red line, around 7,500 RPMs, to make sure the engine is putting out enough power without shaking loose the frame. Having passed the factory trials with flying colors, the Parajet is ready for a sky test. The device breaks down into mission-ready components. In the field, it's reassembled in 5 to 10 minutes. The flyer pulls the starter to get the motor running. Using Kevlar core lines, the flyer connects his harness to the Parajet's wing. It's made of the same ripstop polyester fabric that parachutes are made of. The flyer runs against the wind and takes a flying leap. The test pilot puts the Parajet through demanding maneuvers, banking and diving, and turning the craft by pulling the hand toggles to steer. It is capable of precision flying, multi-range destinations, and can carry up to 280 kilos of pilot and payload. So whether the mission is bringing back intel, getting a bead on contraband, or locating a victim in harsh terrain, the Parajet turns the well-trained pilot into a spy in the sky. And once you see the Parajet suspended in the clouds, you will believe a man can fly. Coming up on Battle Factory, a camouflage jacket that disappears in the dark, and a portable army base that's combat ready in under an hour. This camouflage print was digitally designed under the supervision of the Canadian military's Department of Defense. Then the material is brought here and tailored into a soldier's most versatile action wear, the camo jacket. CADPAT, which stands for Canadian Disruptive Pattern, is the latest in camouflage combat wear. It's made to look good while not being seen. Uniforms were originally made with bold colors, so soldiers were easy to identify in a cloud of artillery smoke. It also made them easy targets. By World War II, GIs were wearing camo, like the American frog skin and the British brushstroke pattern. The CADPAT jacket also camouflages the wearer at night by masking his infrared signature. A classified formula in the dye makes the jacket almost undetectable to night vision scopes. It takes 54 individual pieces of rugged textile to form the jacket, and it will be worn from basic training to the combat zone. The jackets are constructed from 152 centimeter rolls of CADPAT material. A computer-generated pattern for the jacket is printed on a roll of paper that matches the width of the fabric. The paper is rolled out over 200 layers of material, a template of all the pieces required to make the jacket. A razor-sharp blade cuts through all 200 layers at the same time. The pattern's been laid out to maximize the material, so there's very little waste. The 54 individual pieces are ready to be assembled. At the sewing station, it takes 42 people almost 2 solid hours to put the jacket together. The jacket is sewn tough and built to last, with reinforced seams and strong plastic thread. There are CADPAT jackets still in active duty 2 decades after they were issued. Once complete, every jacket gets a careful inspection, testing the Velcro fastenings and pocket strength. Recruits only get 4 changes of uniform for their entire tour of duty, so durability is critical. 1 button out of place, and it doesn't make the cut. As a security measure, every CADPAT jacket gets its own serial number. That way, each and every uniform is accounted for. If it wasn't assigned to you, wearing this jacket is against the law. The CAD-PAT jacket is tested by soldiers for soldiers. On the training field, they'll make recommendations to improve comfort and utility that are incorporated into the new design. Vents along the back and elastic around the torso allow for easy movement. The high-color, indestructible buttons and non-reflective zippers seal the jacket around the wearer and insulate the soldier against the elements. Once it's issued to a recruit, the CAD-PAT jacket will do double duty as training gear and combat uniform. Whether they're shipped out to Kosovo or Kandahar, the uniform will last for as long as the soldier's term of service. And that jacket won't just keep the soldier warm and dry, it'll help keep him alive. Coming up on Battle Factory, no matter where the fight takes you, you've got an Army base in a box. And no matter what the terrain, this craft will get you there. These boxes may look like standard storage containers, but these stackable, shippable units can travel to combat zones anywhere on Earth. And in 30 minutes, they can unfold into a fully equipped military facility. They can be customized into command posts or science labs, hospitals or barracks. These mobile military shelters can create a working Army base in the middle of nowhere in a matter of hours. Each unit breaks down into two parts: a rugged metal container and high-tech tenting that can expand into 27 different workspaces and living areas. The mobile military shelter starts out looking like a standard steel shipping container, but it's about to be equipped with everything you need to make it practical and comfortable, starting with insulation. Every surface is coated with a heavy-duty foam insulation. It's mixed with a chemical called cyanide, so it hardens quickly. Cyanide is highly toxic, so the area is restricted to workers wearing safety masks. Once the insulation is complete, each of the 2,600 parts, including locks, frames, and handles, are painted military green. This reduces the unit's infrared signature, making it tougher to detect. The doors are insulated with rubber weather stripping to protect against extreme conditions. Whether it's 50 above or 50 below, the weather outside stays outside. Next, the container is fitted with wiring to power up everything from radars to microwave ovens. The unit's generator can run enough air conditioning to cool a 3-bedroom house. A fresh air intake keeps the atmosphere inside comfortable. One tank of diesel can put out enough power to charge 2,600 smartphones. Once the unit is assembled and wired, it's ready for testing. It has to be able to weather any storm, so it's put through a high-pressure hose down on all the joints and seals. If it can't handle the outside, they don't start work with the inside. When the Canadian Department of Defense needed to keep warm in the Arctic, a Hercules transport plane airdropped instant shelter onto the sea ice, 80 kilometers north of the most northern landmass on Earth. Once it's passed the water test, the unit is ready for tenting. The exterior metal walls drop down to form the expanded floor, and the built-in tenting material forms the walls. A wafer of high-tech bubble wrap is sandwiched between 2 layers of PVC. This insulates the tenting against Arctic chill and desert heat. The tenting is unrolled and support rods are installed. The expanded unit builds out to 37 square meters of modular floor space. It can be outfitted to any one of 27 different units, including satellite imaging center with radar system tracking device, vehicle repair depot equipped with hydraulic lifts, or a field hospital complete with exam tables and medical equipment. To make the unit transport ready, furniture and gear are locked snugly into the middle of the container. The finished container is secured to the back of a military vehicle and test-driven, hitting the road hard to simulate rough transit. After the shakedown, the unit is parked. The walls come down and the tenting goes up. Every piece of gear is put in place and tested to make sure that when this mobile military shelter is deployed, it will do what it's supposed to do, where it really counts, in the combat zone. Coming up on Battle Factory. When you need to get over land and sea and snow and swamps, this ride feels like you're floating on air. Because you are. When these PVC panels are filled with air, they can transform a boat into a hovercraft. The hovercraft is a hybrid vehicle. Propelled by air, they can float on water, land, ice, or sand, which makes it the perfect vehicle for troop carriers, amphibious assault, and search and rescue. So when an F-16 went down in Utah's Great Salt Lake mudflats, hovercrafts raced to the scene over land and water and were able to reach the pilot in time to carry him to safety and recover sensitive cargo at the crash site. The hovercraft is made of a cab, skirt, propeller system, and an inflatable hull. The high-strength PVC hull has 5 separate buoyancy chambers. Even if 3 of them lose pressure, the hull will still stay afloat. Once the hull is inflated, the frame is lowered onto it. The hull is treated with marine-grade silicone to make sure it slides on smoothly. Then the frame is bolted into place. The skirt is what makes the hovercraft hover. When air is fanned under the hull, it's trapped in the skirt. When the pressurized air exceeds the weight of the craft, it starts floating on that cushion of air, which means the hovercraft can go just about anywhere. To make the skirt, heavy gauge PVC is rolled out onto a table. Using a grease pencil, the pattern is traced and cut. Every piece is made to measure. Heat-activated glue is brushed onto the strips, which are stretched over a skirt-shaped wooden template. Once all the panels have been joined together, the horseshoe-shaped skirt is ready to attach to the hull. The underside has been brushed with adhesive, and the completed skirt is pressed onto the hull. Then it's hoisted and flipped, and the skirt is wrapped around the hull and heat-sealed tight. Then, 16 hollow rubber panels, or fingers, are zip-tied to the bow. When the skirt is filled with air, the fingers create an impact-absorbing curtain around the nose of the craft, which makes for a smoother ride in rough water. If the fingers get damaged, they can easily be replaced or reattached in minutes. The hovercraft is equipped with a variable pitch propeller system. Gimbals on every blade enables the propeller to pivot and rotate on its axis, and gives the hovercraft the ability to brake and glide in reverse. Rotating the propeller on a spindle, the tech checks that all the blades are weighted exactly equally, adding a washer if a blade is even the tiniest bit out. A misaligned propeller will cause major vibrations when spinning at top speed. Once complete, the propeller is mounted in the cage to protect it from getting clogged with bits of debris. 3 rudders are fastened behind the propellers, which directs the airflow and steers the hovercraft, not unlike a helicopter. Finally, the fiberglass cab and seats are dropped into the frame and bolted in. The dashboard containing speedometer and pressure gauges, throttle, and steering systems are installed. The hovercraft is good to go, ready to glide over land and water. With its wide skirt and low center of gravity, the hovercraft is almost unsinkable, even at top speeds of 100 kilometers an hour. Part boat, part airship, all terrain, the hovercraft is mission ready, no matter where that mission takes it.